Okay, today we're going to look at acceleration problems. And so the formula for acceleration is VF minus VI over T. So acceleration is the velocity final, so your final velocity. Remember, velocity is just a speed, minus your initial velocity over time. Or you can do time is equal to VF minus VI over A if it asks for time. If it asks for one of the velocities, you just have to fill in and solve for that one velocity. All right, so let's look at number 1. I'm going to work some of these out with you, and then I'm going to let you work some out on your own. And another thing to remember, these formulas that I've been giving you the last few weeks, the velocity, the speed, the momentum, all of those are on your reference table. You will get that on your test for physical science. So you'll get a reference table, and I'll have all the formulas on there. So you don't have to memorize these. You can just look on there and find it. So if we look at number 1, it says, while traveling along a highway, a driver slows from 24 meters per second to 15 meters per second in 12 seconds. So this was the initial, and then it slowed down to the final, and then this is the time. So it wants to know the acceleration. So acceleration is VF minus VI over T. So the final velocity we said was 15. The initial was 24, and the time is 12 seconds. So if we plug in 15 minus 24, that gives us -9. Okay, and now we're going to divide that by 12. So -9 divided by 12 is going to be -0.75. Okay, so the negative tells us that it's slowing down. So that is slowing down, or a deceleration. Okay, and it says right here, remember, a negative value indicates slowing down or deceleration. All right, if we look at number 3, a car traveling at a speed of 30 meters per second. Oh, and I forgot to put the units on this. Meters per second squared, or sometimes you may see it meters per second those are the units for acceleration. All right, so number 3, a car traveling at a speed of 30 meters per second encounters an emergency and comes to a complete stop. So this was the initial. This is what it was traveling at. It came to a complete stop. That is your final, and if it's a complete stop, that will be 0. How much time will it take for the car to stop if it decelerates at -4 meters per second squared? Remember up here I told you that time could be VF minus VI over acceleration. So the final velocity was 0. The initial velocity was 30. And then the acceleration is -4. So we're going to do -30 divided by -4, and that comes out to be 7.5 seconds because it's in meters per second. You should not get a negative time. You can't have negative time. You can have negative acceleration because you're slowing down. Positive acceleration speeds up, negative slows down. All right, if we look at number 5, a cart rolling down an incline for 5 seconds has an acceleration of 4 meters per second squared. If the cart has a beginning speed of 2 meters per second, what is its final speed? So this is the initial, and that's it wants to know the final. So we're just using acceleration is equal to VF minus VI over T. So the acceleration is 4, that was right here. We're solving for VF, so we're going to subtract away VI, which we said was 2, and the time is 5 seconds. Okay. To get that 5 seconds off of there, we're going to multiply, because it's divided, we're going to multiply it by 5 and multiply this side by 5. So now it becomes 5 times 4 is 20 is equal to VF minus 2. We're going to move the 2 over here now, so it'll be 20 plus 2, because when you move it to the other side of the parentheses, it becomes the opposite of what it was, so it'll become a positive over here, is equal to VF. So VF is equal to 22. And if you can, get in a habit of putting a box around your answers. It makes life so much easier as a teacher if you box your answers. All right, if we look at number 7, this says, as she climbs the hill, a cyclist slows down from 25 miles per hour to 6 miles per hour in 10 seconds. What is her deceleration? First thing we're gonna have to do is change the seconds into hours, because this is all in miles per hour. Okay, so to change it into hours, we first have to change it into minutes, so we're going to divide by 60 to get it into minutes. So 10 divided by 60 is going to be 0.167 minutes. And then we're going to divide it by 60 again to give us 0.0028 hours. Okay, so we've got that changed into hours. Now we're just going to solve it. So it wants to know her deceleration. We're still just looking for acceleration. It's just going to be a negative acceleration. All right, so velocity final, she slowed down from 25 to 6. So this would be the final, this would be the initial. So we're going to do 6 minus 25 over, our time is 0.0028 hours. So 6 minus 25 is negative 19 divided by 0.0028. So that gives us negative 6,785.71. This unit seems a little bit high because we're working in miles per hour. Usually we're doing meters per second, so that's why it seems a little bit different. 9, a car starting from the rest accelerates at a rate of 8 meters per second. So it started at rest, so that was our initial. So initial is going to be 0 because it's at rest, and it went to 8. That is our final. Oh, no, sorry. That's your acceleration. It wants to know the final. All right, so it gave us acceleration. It said it was at rest. It went for 4 seconds, so we're just going to plug in. So we're plugging into A is equal to VF minus VI over T. So our acceleration was 8. Our final velocity is what we're solving for. Initial velocity was 0, and that's over 4, which is the time. So we're going to multiply this 4 off. 8 times 4 will give us what it is over on the left-hand side. So that's going to be 32 is equal to VF minus 0. The 0 doesn't really matter. If you take it over here and add it, it's still going to be 32. So VF is equal to 32. And we wanted to know the final speed, and that is in meters per second, because their stuff in here is meters per second. And if we look at number 11, okay, number 11 says a cyclist accelerates at a rate, so this is the acceleration, of 7 meters per second squared. How long, so we're solving for time, will it take the cyclist to reach a speed of 18 meters per second? That's your final speed. Initial, if it doesn't tell you initial, you're assuming that it's starting out at a stop. So our initial is going to be 0. So we're going to plug into A is equal to VF minus VI over T. So our acceleration is 7. How long? Oh, well, I can solve it like this. I should have just set up the time thing, but we'll do that. All right, so we've got VF is going to be 18. Initial was 0, and we're solving for time. So we're gonna get the time off of it by multiplying it. So we have 7t is equal to 18. So 18 divided by 7 will equal t. So 18 divided by 7 is 2.57 seconds. Okay, so I've solved the odd ones on this sheet. You need to solve the even ones on it. You can do that on a separate sheet of paper. All right, if we look at this one is posted in your class also. We're gonna go through this. It's the same formula, it's just some different problem sets. So we're still using acceleration is VF minus VI over T. All right, so let's look and see what's in the problem. Roller coaster rapidly picks up speed as it rolls down a slope. As it starts down the slope, its speed is 4 meters per second. So that's the initial. 3 seconds later is your time. The bottom of the slope, its speed is 22 meters per second. That's your final. It wants to know the acceleration. So we're gonna do VF, which is 22, minus VI, which is 4, and it's over 3 seconds. So we're gonna do 22 minus 4 divided by 3. The acceleration is 6 meters per second squared. Okay, let's look at number 4. Number 4 says a lizard accelerates from 2 meters per second to 10 meters per second in 4 seconds. What's its average acceleration? VF minus VI over T. So the final velocity was 10, so we're gonna do 10, minus the initial, which was 2, over 4. So this is gonna be 8 over 4, which is going to be 2 meters per second squared. Okay, so for this one, I want you to solve 2, 3, and 5. Make sure that you show your work on those. You can do it on a separate sheet of paper, take a picture of it, and turn it in. You also have to turn in notes that you took on this. So you have to show the notes that I gave you. Thanks.